Hi everyone, it's Marika Lamro, and this little video is going to walk you through the steps of calculating a dependent samples t-test. So first I want to show you guys what I hope is this inspirational photo. I know that sometimes statistics can be overwhelming, and I know that sometimes you feel like you can't do it, and maybe looking at this photo and the quote helps you feel like you can do it. Okay, here is the sample problem that we're going to use. Pause the video and read it, and when you're ready, unpause the video and we will carry on. As always, the first thing that we need to do is to state the null and alternative hypothesis. In this case, the null hypothesis is that exercise type does not influence how much water athletes drink. And when we state that mathematically, you say H naught is that the mean of the weightlifting group equals the mean of the cardio group. The alternative hypothesis is that exercise type influences how much water athletes drink. And you say that the alternative hypothesis is that the mean of the weightlifting group does not equal the mean of the cardio group. So here are the formulas we're going to be using. All those D's that you see stand for D score, difference score. So we're first going to calculate the difference score, and while that might sound really crazy, it's actually really straightforward. So we have our weightlifting group and our cardio group, and to calculate the D score, you just subtract one from the other. Now you always need to subtract in the same direction. So if you're doing weightlifting minus cardio, you need to do weightlifting minus cardio for every single person. Or if you're doing cardio minus weightlifting, you do cardio minus weightlifting for every single person. You can't switch back and forth and sometimes do weightlifting minus cardio and sometimes cardio minus weightlifting. So you can see the way I calculate a D-score is I always do the left column minus the right column. And so now those are our D-scores. So we're going to calculate our sum of squares. Oh, sorry. First we look at the mean of that sample, and so the mean is negative 0.6. And we calculate the sum of squares by doing the D-score minus the mean of the D-scores. And then we square that, and we add that all together, and we end up with our sum of squares. I hope that that is really straightforward, that you guys are really comfortable with calculating the sum of squares, but I have this up there just so that you can see how you calculate the sum of squares for D-score. And back to the formulas. Now that we know our sum of squares for the D-score, we can calculate everything else. Assuming that you can calculate the sum of squares of the D-scores, that equals 7.2. We know our degrees of freedom is going to be the number of D-scores, which is 5, minus 1, so our degrees of freedom equals 4. Once we have our degrees of freedom and our sum of squares, we can calculate the variance of the D-scores, which is going to be 7.2 over 4, which equals 1.8. Once we have the variance, we can calculate the standard error of the mean of the D-scores, and that's going to be equal to 0.6. Once we have the standard error of the mean of the D-scores and the mean of the D-scores, we can calculate T. And I'm going to explain a little bit here why that mu sub D turns into a 0 in this formula. Most of the time, you can assume, or I should say, all the time you can assume that you're looking to see if there's any difference between those two samples. But occasionally you might say, well, I'm really interested to know if there's a difference that's larger than 0 between those two samples. So you might say, I want to know if people drink more than 1 glass difference between weightlifting and cardio. So if you are trying to see if there's a larger difference than a certain number, then that's what you'll put in that mu sub D area. But generally, you're just going to be able to put a 0 there because you're just looking at, is there any difference at all? I don't care how big that difference is, I just care if there's any difference at all. And so you put a 0 there because a 0 means any difference, no matter how small, is what I'm looking for. So in this class, you can always assume that you're looking for a difference of 0. Any difference greater than 0 is going to be relevant, and you can always put a 0 for that mu sub D. And when you do that, you come to a T formula of negative 0.6 over 0.6, and the t equals -1. And now we can calculate the effect size, Cohen's d, and that equals -0.45. Another thing that I want to point out that can be a little bit tricky about a dependent samples t-test is you have two different d's. You have the capital D, which stands for the D score, and you have the lowercase d, which stands for Cohen's d, and is your measure of effect size. You don't really need to worry about the D score D, the capital D, when you're reporting things, because you're only using that when you're calculating the t-test. The Cohen's d is for when you're reporting things and you're reporting your effect size. And you can always tell the difference between them because the D score D is always capitalized and the Cohen's d is always lowercase. So just remember to keep those two things separate and you should be fine. So we go back to our very friendly t-table. This should be really straightforward now. Now that we have a D score, we only have to worry about the degrees of freedom for one sample. So this should be just like a single sample t-test for you. You should be very familiar with this. You have one degree, or you have one thing for the degrees of freedom that you need to worry about, and that's the number of D scores. And it's the number of D scores minus 1, and since we have 5 D scores, our degrees of freedom is going to be 4. Again, you're going to assume that it's an alpha of 0.05 and a two-tailed test, which means we're right there. You put your two fingers together and you come up with an t-crit value of 2.776. Remember that our calculated value of t is -1. So our t-crit is greater than our t-calc, which means that p is greater than 0.05, which means p is that we do not have a significant t. So now let's look at how that all breaks down. We know that our t-crit is less than our t-calc, which means that we retain the null and we fail to support the alternative hypothesis. And so that means our null, which is that exercise type does not influence how much water athletes drink, has been retained. So what does that look like when you write it up in APA style? It looks like this. People drink the same amount of water whether they do cardio or weightlift. And that's it. That's how you calculate a dependent samples t-test. It's really straightforward. It's very similar to a single sample t-test, so it should be very comfortable for you. As always, if you feel like you need more help, please feel free to email me or to come to my office hours. Email the TA, go to the TA's office hours, contact a classmate, or go to the tutoring center. I never want you guys to feel like you are swimming without any support, so please feel free to use any or all of these if you want more support.